Hello, everyone. Good morning or good afternoon, depending upon where you are in this country, in this world. My name is Daniel Moyer. Welcome. Today, what we're going to be talking about is harsh environments training. We're going to talk a little bit about how lithium-ion batteries of any manufacturer special considerations have to be made when we're going to install them in cold weather environments and hot weather environments. We're also going to talk a little bit about humidity, altitude, and even mobile applications as well. So thank you for joining. This is a NABCEP accredited course. So if you're looking for your NABCEP credits, at the very end of this training, I'm going to have my email going to pop up. Go ahead and email me your full name, spell it out for me, full last and first name, so that I can get the spelling right on your credentials for your continuing education NABCEP credit. Additionally, another housekeeping item is that if you have any questions during this talk, I can't unraise your hand. So go ahead and pop your question into the Q&A chat, and we can answer the questions. One thing I've always liked to do during these trainings is let's have a little game. So, and just so I know you guys can hear me and see me okay, is what is the forecasted high for today in your area? I personally live right on the coast of California, Northern California, so we're going to be lucky to hit the upper 60s. But as we're coming into spring, let's see who's going to have the highest, warmest forecasted high temperature for today. And if anything, somebody can also chime in what their coldest forecasted temperature is for today. That's where we can really see some of the variations across this industry. So go ahead and put it in the chat if you want. What's your record? What's the forecasted high temperature for today for your area? One thing I want to start off is we have a lot of other training opportunities besides one of these live training sessions that you're seeing now. We also have the Power Academy, and I'm going to show you a little bit later on in this presentation how to log into the Power Academy. Additionally, we also have a training calendar on the SimpliPhi Power website. So we're going to talk here in a second about how Briggs and Stratton acquired SimpliPhi Power and is now able to offer both a full line of generators and also a full line of energy storage systems. And part of the acquisition by Briggs and Stratton was the opportunity to use the Power Academy. So I'll show you a little bit here near the end how to log in, how to start accessing some of those resources. There's no need to log into the training calendar. So we can go ahead and click on that link or follow that URL there. Once you get this slide deck, I'll send it out after the end. So I see a couple people chiming in on the temperatures. Somebody says an 88-degree high and a 60-degree low, 51 degrees Fahrenheit high, 41 degrees low. So a lot of people coming in. I think the winner is going to be a Philip. He says a 94-degree Fahrenheit high temperature. So as we're coming into spring, summer, we're going to think about high temperatures, but a lot of times we're talking about low temps. And I was recently in Arizona, in Phoenix, Arizona, talking to a generator installer and getting them excited about starting to enter into the energy storage market. And guess what they had concerns for in Phoenix was high temperatures. But I also see low temperatures becoming more and more common of questions as a lot of northern states like New England, like our Montanas, like our Michigans, are starting to get more common with the energy storage installations. So we're going to talk a little bit about that. A couple really quick things, kind of the sales pitchy stuff at the beginning. I'll get through this quickly and get to the meat of our topic today. But really, SimpliPhi Power, Briggs and Stratton has been known for safe, proven, and simple technology, right? Our safe technology is basically based off of our cobalt-free chemistry with that no risk of unmitigated thermal runaway with fire propagation. And that word unmitigated is the key word there. You can still have thermal runaway with lithium iron phosphate cells, which is the chemistry we use. But what happens after it goes into thermal runaway? Does it kind of just put itself out, or does it continue with that unmitigated propagation, spreading cell to cell, maybe battery to battery, or even battery module to battery module in a larger system to system. We have some UL certifications. I'm going to talk about those a little bit later. UL 1642 on the cell level, UL 1973 on the battery module level, and UL 9540 on the system level. And I'm going to talk a little bit about what UL 9540A is here in a little bit. We also have Department of Transportation. 3480 allows us to ship these batteries to all you guys, LTL, right? Less than truckload. But we also hold UN Department of Transportation 38.3, which allows us to airship these batteries. Proven. We're one of the few companies that's been around longer than some of our battery warranties go for, right? So we offer a 10-year warranty on our battery, and we've been making batteries for longer than 10 years. So we do see some of our batteries out there in the industry, in the field, outliving their warranties. Deployed in many countries around the world. We also had a great opportunity to be tested and validated by the US Army and Marine Corps. I'm going to talk a little bit about that later, but essentially, right at the beginning of our start of manufacturing, 2010, which is kind of ancient history when the whole realm of energy storage, well, at that time, really lithium-ion batteries were making the news for being unsafe. There were a lot of cobalt-based chemistries on the market that were going into these unmitigated thermal runaway events. We approached the Department of Defense saying, look, we have a safer chemistry and a safer form factor, cylindrical cell. Why don't you give us a test, try it out? And so ultimately they took our batteries out to the Aberdeen Proving Grounds and subjected our batteries to really high vibration, high temperature testing. And they actually agreed and loved what they saw. We did further deploy with some of their units and forward operating bases in the Middle East. We do have a business model that can demonstrate social impact and profitability can coexist, kind of the so-called triple bottom line. And if you're somebody out there that has an idea, we do give back, usually in the form of battery donations to clinics, to schools, to other type of humanitarian relief projects. So if you have an idea, wait for my email at the end of the presentation, and we can talk a little bit more about what maybe your idea is. Simple, what we've always been founded on, and as you can see down there in the bottom left corner, our batteries really still are inverter agnostic and charge controller agnostic. As long as you take one of our batteries and perhaps you replace some lead acid batteries, get into that inverter, get into that charge controller and adjust the set points so that you're treating the batteries the way they want to be treated. I'm thinking of our float voltages, disabling, equalize, the bulk voltages, max charge, max discharge amps. So whether you got Victron, SMA, Schneider, Samlex, Outback, right? You can get into those systems, adjust the set points, and start utilizing our batteries. Well, of course, we do have our own vertically integrated system now. It's kind of right there under the SimpliPhi ESS banner. It's our own inverter, our own battery that pairs with the inverter, and our own app. And I want to be careful not to just skip over the app, because I realize a lot of homeowners and a lot of installers now are looking for a kind of that third leg of the stool, an app that shows them exactly what their battery reserves level are, maybe make adjustments to hold in reserve or put the system into a storm watch mode. Also, the installers really like a good app because it allows them to do remote reconfiguration, keep an eye on their homeowner systems, and also do firmware updates over the air. So again, we've always been known for utilizing our batteries with a lot of other people's equipments. I'm excited to now offer a vertically integrated system, one warranty, right? One tech support call. And one thing, lastly, on this slide is our high voltage solutions. At some of the more recent solar trade shows, the excitement around high voltage battery lines is just growing. And I see this really coming out of small commercial and industrial systems. I'm thinking of the SolarArc 30K or the SolarArc 60K that now has 3-phase 208. And so if you're somebody that's into that and doing that, look for some of our pre-packaged high voltage solutions. If you look at a spec sheet on a SolarArc 30K, it needs like 150 volts DC on the battery side to get that inverter to wake up. So we do have some of this is a containerized solution you're seeing down in the bottom right, but there's also some rack mounted systems that are a little smaller scale. I'm thinking of like a server rack for computers. So again, a lot of these products are there to simply integrate into what you got, creating that resilience and energy security that homeowners are looking for.
Daniel, on the high voltage side,
Welcome, Nathan.
Up to 1200 volts, and we're also looking at 3-phase 480 systems as well with our projects team. So if that's an interest of people, you can reach out to the training team and we'll connect you with the engineers that design those systems.
Yeah, thank you. And I didn't introduce Nathan Heston is on the line with us. He's one of the other trainers here. And Nathan and I both have our own expertise. So I'm looking forward to Nathan helping me out on some of these slides where I need a little bit extra help. But absolutely right, Nathan. We have lots of different options for that high voltage. Thank you. Really quickly through the history, back in 2010, we were one of the first companies to come to market with a lithium iron phosphate battery. We were tested by the military. We really began to expand our product line through the years to develop residential systems and even into commercial systems. Within 2020 and more recently, we were acquired by Briggs and Stratton. I'm really excited about the acquisition. It really gives our batteries a name brand, a household name that people can recognize. And when you and I, as a solar install, maybe walk into one of these large trade shows, and we recognize a lot of the names in that trade hall, but your average homeowner doesn't. And a lot of times when you can build a brand name that people recognize, they're more likely to buy that system from you. These are the driver and needs. I don't need to go too deep into this. We all know that home is a haven. This really came out of the pandemic where people are working from home, people are learning from home, and they want to have that independence. We all know that the infrastructure in our country isn't being kept up the way it should be. It's failing infrastructure, old infrastructure. And it's also really scary to think about how vandalism is starting to affect our power grid. The idea that somebody with a rifle can shoot up a substation and knock out power to half a state is pretty scary. Well, offering your homeowners, offering your business owners that backup resilience to not only give them backup, but potentially also save them money through time of use arbitrage and peak demand shaving is of great value. Climate-related disasters also affect our power grids. Hurricanes, ice storms, high wind events here in California cause our power lines to sway in the wind and cause fires. Well, our local utility, Pacific Gas and Electric, will preemptively shut down the power grid during high wind events so that they're not going to be responsible for fires. Of course, they're trying to bury all the power lines right now, but still, that's going to take a long time. Electrification of everything. I'm thinking of heat pumps is definitely a growing trend in a lot of markets, not only for space heating, but also for water heating. EV chargers are really coming online. And there's a lot of opportunities right now around green subsidies. I'm thinking of the new ITC that recently came into effect where they're, I got that slide wrong. I need to change that to 2033. But really what they're offering is a 30% tax credit for the next 10 years. And notably, it can be leveraged on just storage without solar. Historically, you would have to install solar and storage together to leverage that 30% tax credit on your storage. Now you can come in, add just storage, leverage that 30% tax credit. A lot of opportunities in the end use applications, upgrading an existing home that already has solar on the roof, and now they're looking to add solar. It's going to be a huge market. Time of use arbitrage, let's shave off those high expensive times during the day and use the storage, the battery storage to then power our homes. We can tell the energy storage system when those time of use rates are, and the system will automatically act accordingly. Selling power back to the grid. Off-grid living has been where we all got our start, and that's kind of where I got my start working for Sunfrost, which was a DC refrigerator manufacturer for years. I also see an opportunity for coming into older pieces of equipment where the warranty may have expired, and then go ahead and swap in a new inverter, a new energy storage system, and bring that warranty up to a more recent, to bring the warranty up to a brand new warranty. Peak demand and demand management, that's more on the utility side, but again, that's going to be a growing opportunity. So I think I'm going to ask Nathan here to chime in a second. I really want to ask him, here's the question. I understand, Nathan, that we have LFP, lithium iron phosphate, is our chemistry, which is the safer of all the chemistry. And we also use a cylindrical form factor. Now, the meat of today's subject is I'm going to kind of focus on cold weather applications on freezing. So you can see here on the right-hand side is kind of what it looks like in a cylindrical cell. We have the cathode side and the anode side. So Nathan, why is it bad on kind of a physics level to charge a lithium ion battery when it's below freezing?
So the freezing point is not exactly the temperature that matters. These are not aqueous batteries. There's no water in there. But at low temperatures, the intercalation process, the movement of the lithium ions between the layers of the graphite is drastically slowed down. And there are several reasons for that. The electrolyte becomes much more viscous, but the lithium doesn't move quickly into the graphite. And so at low temperatures, the lithium can end up getting stuck outside the graphite and even forming solid lithium deposits, where you basically are creating lithium metal and having the lithium ions that are in the electrolyte solution form what are called dendrites, and that word means branches. And so the growth of lithium on the graphite layer can actually, if you do this, over time, build up to the point where it could even short circuit a lithium battery. And so this is a problem for all lithium batteries, is the ability to charge at low temperatures. We have a solution for this, and Daniel might talk about it a bit later. But that's the reason. And that intercalation process being slow is something you can overcome by slowly warming up the battery.
Thank you, Nathan. This was, and I have to give Nathan credit for this slide. This is something he recently came up with. And what we're looking up here is we have essentially two types of batteries. We have batteries, all of our batteries use lithium iron phosphate, the safer of the chemistries. All of our batteries use a cylindrical cell. But one line of our batteries, the Phi battery that you see there on the top, does not have closed loop communication capabilities. It does have an internal battery management system that analog that allows it to mainly be there for cell balancing, and it can open up if it sees conditions that it doesn't like too high a voltage, too low a voltage. We have a second, more advanced type of battery management system that's found in our SimpliPhi batteries, and that does have closed loop communications that can talk to a piece of equipment that can listen and listen to what the commands the batteries are saying. So internal in the SimpliPhi battery is a thermistor. So it knows its internal cell temperature. And based on that internal cell temperature, the digital battery communicating battery management system can tell a piece of equipment to slow down or even potentially completely stop a charge or discharge cycle. So if we have that capabilities in place, we're letting you kind of operate the discharge temperature and charging temperature of a communication capable battery, the bottom one, a little bit of a wider window. If you don't have that ability to communicate and tell a piece of equipment to slow down the charge rate, that we're really wanting you to maintain what you're seeing at the top, a little bit of a smaller temperature window. Should be noted that you can really discharge or have these batteries sitting idle at a larger temperature range than you can at charging. For the reasons that Nathan just explained, when you charge any lithium ion battery, not just ours, you're going to damage it. And so if you don't have those protections built in, let's go ahead and keep our temperature windows a little bit more narrow. And that's going to require us to, and we're going to talk about battery warmers, insulation, and even ventilation systems as we get into high temperatures. Nathan, was there anything you wanted to add to this slide?
No, we've got a good question that came in. It's from Chris Schaefer. He's looking at installing in Canandaigua, New York. And he's asking, so how does one determine when a battery is too cold and shouldn't be charged in a normal manner? And so, Chris, one answer to that is that there are external temperature monitors that you can buy for batteries that don't have temperature sensors built in. The SimpliPhi battery that Daniel's talking about has multiple temperature monitors built into the battery pack. So the battery pack is a fairly sophisticated piece of equipment, and it has temperature monitors, 3 different temperature monitors that are monitoring the pack temperature in different locations, as well as temperature monitors that are monitoring the battery management system, which is known as the BMS. And so the SimpliPhi battery senses the internal temperature, which is what we want to pay attention to. That's when we're talking about the range of temperatures the batteries are able to function at and charge at. It's the internal battery temperature that matters. And so the internal battery temperature in the SimpliPhi is monitored by the BMS, and it uses that information to be able to communicate out to the charging equipment how quickly it can be charged safely. So it's a great question. If you have batteries that don't have that internal temperature sensor, you can always buy external temperature sensors, which will integrate with most modern charging equipment.
Yeah, thank you, Nathan.
And so if you have the specific equipment, you can call us and we can talk to you about how to do that as well. And Daniel's going to present some other solutions for cold weather here in just a few minutes.
Yeah, thank you, Nathan. And that's an important thing that Nathan just talked about, is we have to understand the temperature gradient between what ambient might be and what the internal temperature of battery may be. And that gradient can be pretty wide. The other point that Nathan made is that if you are going to use an external temperature sensor, where should we place that? Maybe we could sandwich it between 2 adjacent batteries. So although we're still an external temperature sensor, we're trying to capture that internal temperature. So again, talking about communicating batteries have the ability to tell a compatible charging equipment the appropriate charge rates, and then using those multiple internal thermistors that Nathan was referring to, really it can establish a safe charging parameter. It's also notable that you can store these temperatures, store these batteries at low temperatures. I'm thinking of a lot of the winter cabins that we see a lot, where people leave the cabin unattended for months at a time, and you can then keep these batteries there. Ideally, you would want to disable the charge cycle. And then I always get the question, well, if we're not charging the batteries over winter, are they going to self-discharge? The answer is yes, they will, but at a very slow rate, about 1% per year. Whereas not you'd see in your truck battery or a car battery, a typical lead acid battery is going to be discharged a lot quicker. So you know that if you're discharged, get them on a full charge, shut the cabin down, and know that when you come back in spring, your batteries are still going to have a good amount of charge. Of course, put them on another charge cycle when you come back to the cabin before you start turning on your load breakers.
So Daniel, that's a great point on storage of batteries, and the low temperatures are bad for the charging of the batteries, but the batteries themselves don't have any problems with being at low temperature, even freezing temperature, if they're not being charged. I'm thinking back to the very first battery I got back in the early 2000s. It was a lead acid battery, and it was a deep cycle battery. And I was in a location that was so cold, the battery actually froze and burst, and that's because it has water inside of it. And so even with the sulfuric acid in there, lead acid batteries can actually get damaged and bulge out if they freeze. Lithium batteries, they don't have this problem, but as Daniel said, you want to make sure that you turn the charging equipment off if you know that the system is going to be very cold.
Exactly. Thank you, Nathan. This is an example right here of the Phi battery. Again, this is the one that does not have that built-in ability to communicate. So we want to be very careful that if we're going to be charging this below freezing in below freezing ambient environments, that we're protecting it properly. Whereas the SimpliPhi battery and also our 4.98 SimpliPhi battery do have that intelligence and that control in there to allow more of a flexible installation when it comes to those more extreme temperatures. Again, and just to expand on this a little bit, there's 2 layers of protection, really. The battery is going to tell that piece of equipment, the inverter, the charge controller, what to do. And even if for whatever reason the piece of equipment does not listen, the battery management system can still open up, disconnect itself to protect itself internally. Speaking of outdoor ratings, outdoor rated enclosures, we have some of our Boss cabinets. What you're seeing on the left is our Boss 6 cabinet that's able to hold 6 batteries. The Boss 12 cabinet that you see there in the middle, and finally our Access cabinet on the far right. And I've seen people put, and I'll show you a couple pictures of what insulation can look like. You can line the walls of these cabinets with insulation. I've also seen people put insulation under the batteries, because if you think about this battery cabinet, it's a giant metal cabinet, right? So there's a few ways to lose heat, right? Through conduction, convection, and radiation. So if we can prevent this metal cabinet from radiating out the heat or through conduction, we can keep the batteries a little bit warmer and use what little internal resistance there is in a battery that's generating its internal heat to contain that heat and keep it where we want, which is near the cells, to keep them a little bit warmer. So it's
a good point, Daniel, that I'm going to touch on here. We just had another question come in about the capacity of batteries at low temperature. And so as Daniel mentioned, lithium batteries have very low internal resistance, but there's a little bit of internal resistance there. And what that means is when a battery is discharging, a little bit of the energy, and we're talking less than 2%, is converted to heat inside the battery. And so the question that came up, Daniel, was, what does the capacity of a 3.8 kilowatt hour battery look like in low temperatures? And the answer to that is that it's very hard to maintain a low temperature on a battery cell as it's discharging at high rates. So if we're discharging at a recommended C/2 discharge cycle, the battery cell temperature will rise during that discharge cycle. And so if you were able to maintain a temperature really low, the batteries wouldn't go through a full discharge cycle because of the increased internal resistance at low temperature. But typically, and I was just talking last week with our lead engineer about this, the battery temperature typically rises up towards about 20 to 25 Celsius, even in cold ambient conditions during a discharge cycle. And so what that means is that we get very close to 3.8 kilowatt hours out of the batteries, even when they're discharging at 0 degrees Celsius temperatures. And so anywhere, once that ambient temperature is above 0 Celsius, the battery will typically warm up to above 20 Celsius. And from about 20 Celsius, you're looking at about 3.6 kilowatt hours. And once the battery temperature reaches 25 Celsius, you're much closer to getting the 3.8. And then it actually goes above that as the battery temperature goes up to 30 and 40.
Thank you,
hopefully
Nathan.
that answered that question. It was probably more detailed than was wanted. And I'll talk about this again in next week's training.
Yeah, no, that's great. So yeah, so again, what Nathan, just to distill what Nathan said, is the battery warms itself up as it's discharging itself. So again, this is going back to what we were mentioning earlier, is that, just because ambient temperatures may be really cold, doesn't mean that the internal battery temperature is going to be that cold, especially if you start to consider this picture here, like that example that, I mean, you can see how steep those solar modules are kicked up. So this is a very high latitude installation, and that little power shack behind the solar modules is insulated. So you can see that, based on several layers of insulation, what is going to be ambient isn't necessarily what's the internal temperature. So again, the gist of today's talk is, exposure to cold temperature without some of these design considerations is really going to reduce the ability of your battery to perform, and could potentially even damage the battery permanently. Going back to the Phi battery, I just want to drive this point home. There's two types. It's a Phi battery, non-communicating. If you're going to be in a situation where you are going to be exposed to freezing temperatures, let's go ahead and consider the Amplify battery that does automatically reduce its charge rate. Here's a couple of examples of what some of the insulation can look like. We can use, I've seen even people put foam insulation on the outside of battery cabinets temporarily during winter and then remove them. I always like to see it kind of on the inside so it's permanently mounted, and also be sure that you can put the insulation under the battery so you're not getting that metal battery shell to metal battery cabinet conduction that's occurring, that's going to kind of pull the heat out of the battery. There is battery warmers, and this is a picture of one of them there. These battery warmers usually go underneath the batteries, and there's a thermostatic sensor that we can install internally in the battery. So we're measuring internal temperature, and these battery warmers will then cycle on and off to keep the batteries above freezing. It should be noted that, of course, that energy to power these battery warmers has to come from somewhere. And if it's an off-grid situation, it's usually going to be from the battery. So make sure we account for that consumption of needed to generate the heat when we're sizing our system.
So Daniel, this is a good point here on the battery warmers. Yes, they can be used when they're off grid, and these battery warmers can also be placed on top of insulation. They are a special order item, but if you're doing cold weather installs, these get wired directly into the battery management system, and they can be installed on either the SimpliPhi or our Phi batteries, but they are special order. It's about $500, maybe a little less than that, per battery to have these built in, but they're great solutions for cold weather environments if it's needed.
Yeah, great point. So Nathan's point there, I'm gonna just reiterate that I keep saying that, you know, if you got cold weather, use the SimpliPhi because that's the one that knows its internal temperature. That doesn't mean that you couldn't still utilize the Phi battery and then leverage these battery warming pads, which are going to keep that battery warm. Absolutely. Thank you, Nathan, for chiming in on that. Like Nathan had also mentioned earlier, there are third-party devices that can be used to control the charge of the batteries. And then these external third-party devices with external temperature sensors can then look at the battery temperature. And ideally, we could probably sandwich that thermistor between two batteries. So we're trying to replicate what we're seeing as the internal temperature of the batteries. And then that's going to adjust the charge rate. Victron is a great example of something that can be used to leverage that. Hot temperatures is another interesting, and as we're kind of coming into summer, I think this is going to become, more of a common topic. Really the battery cabinets that we offer, the Boss 12, the Boss 6, do have ventilation fans that are drawing air through that. Now, that being said, if we're in Phoenix, do I want to see one of these battery cabinets mounted on the south side of a house? No. I'd like to see them mounted in some place where we're going to keep them out of direct sunlight. I think that can be said for any kind of electronic device. A lot of times that's not always possible, right? What if we have to locate this next to a main electrical panel or our meter? So again, when we're talking about high temperatures, there's other variables that we need to talk about. And Nathan, I'm going to put you on the spot again. What can happen to a lithium-ion battery if it gets too hot?
If you get too hot, the electrolyte, which is an organic solution in there, you can think of something kind of like a gasoline or a diesel, although it's definitely not that. But it's that kind of a consistency in it, and it can vaporize. And so if you get too hot, the organic solvent that's in there, the electrolyte, can turn into a vapor and pressurize the batteries. And if the batteries get to a high enough internal pressure, there's a vent on the top. And so if you get to a pressure about 10 times atmospheric pressure, the vent is designed to release so that the batteries don't explode. And that's what's called an off-gassing event. That typically only occurs if there's maybe been a fire in the building and the batteries get very hot. But in an off-gassing event, the battery electrolyte is what actually burns. So when you watch a lithium battery fire, that's actually what's happening. And typically those fires are much more common with cobalt-based chemistries, which we don't use.
Thank you, Nathan. Again, it should be noted that we can utilize insulation to help keep those batteries cool. I live, like I mentioned earlier, about half a mile or a mile from the Pacific Ocean. So humidity, salt sea spray is definitely a concern about this. If you are going to have this be a concern, I've even had our jurisdictions, our inspectors require us to install these battery management systems, not just SimpliPhi, Power, Briggs, and Stratton, but other manufacturers inside. The batteries themselves have a metal case, we do actually offer an ability to install these batteries in a ABS plastic case. And some of our smaller 1.4 batteries by default come in a plastic case. So if you really are in a situation where you're really concerned about humidity, like a boat, marine application, or right on the ocean, start to think about why you should keep them out of that condensing atmosphere, keep them inside where the humidity is lower, and then also maybe talk to us a little bit about leveraging some of our ABS plastic cases that are less prone to corrosion. Altitude, what I've always noticed is that there's usually an altitude limitation on the inverter, and there's also an altitude limitation on the batteries. And as I mentioned earlier, we use lithium iron phosphate as our chemistry, but the form factor we use, the cylindrical cell, think of them as like little AA or AAA batteries, is able to contain pressure differences better than, say, a pouch cell, which is what we see in our phones and our laptops. It is essentially just kind of wrapped in aluminum foil, which doesn't necessarily have the strength to kind of work against those atmospheric pressures. So always take a look at your spec sheets on the batteries of any manufacturer and your inverter to make sure that you're not exceeding that altitude limitations that you might see. I could maybe put in the chat who thinks that they're at the highest altitude today. It's probably going to be somebody from Colorado that's going to chime in there. But again, keep in mind, for a lot of us across the country, this isn't really going to pertain to us, but there is opportunities. I know in the Sierra Nevada mountains and the Colorado, Utah's area, that this is something that's at the top of their mind. So again, there's no—
Daniel, I want to be very clear here. We actually don't have any altitude limitations on our batteries because we use a cylindrical form factor. It's a more expensive battery cell than prismatic cells. And it's just due to the nature of the fact that cylinders are much better able to hold shape at high pressures, right? That's why propanes, and pressurized containers are always built in a cylindrical design. So if you are using prismatic cells, be very careful about taking them to very high elevations because they don't have that same advantage,
or
right?
pouch
And
cells.
so, yes, or definitely pouch cells. I just pulled another burst pouch cell out of a phone last week. But yeah, our batteries can go to high elevations, but typically at high elevations, you have to be careful about temperatures. And that's a concern that we're spending most of our time on today, is making sure that you're not charging at really low temperatures unless you're using, the SimpliPhi battery, and then charging has to be slowed down through the use of communicating equipment, compatible communicating equipment.
Yeah, thank you, Nathan. And speaking on that, that's one of the ways we were able to obtain our certificates to airship these batteries. Because if you think about what does the cargo hold of an airplane look like, well, you're going through rapid temperature swings and rapid pressure swings. So having that cylindrical cell is great for safety, not only for these altitude changes, but also it helps contain any thermal event that might happen. So vibration, I'm really excited to talk a little bit about the mobile market. This may not be the topic that everybody here on the call is interested in, but I've always been blown away. I live on the Pacific Coast, so I see a lot of people traveling up and down the West Coast in these camper vans, these RV vans, but more recently, these van conversions, where these Sprinter vans or these Dodge Ford Transit vans, where people spend a lot of money to outfit these kind of expeditionary vehicles. And when you're thinking about, you got a battery in these systems, there's a lot of vibrations. You're traveling down the road. And so although our batteries are not tested specifically for that standard, we do have that the UL listings that did put them to shock and vibration. If you are going to be utilizing some of our batteries, I would argue anybody battery in a mobile application, situate the batteries where they're not going to be right over the axle, right, slamming up and down. Situate the batteries underneath some insulation or some sort of shock absorbing mat that's going to kind of absorb some of those shocks. Again, maybe start to think about some of our 1.45 batteries that have a smaller form factor, come in 12 volts, and leverage that ABS plastic case for corrosion prevention. So really excited to say with the acquisition of Briggs and Stratton, they've really doubled down on our ability to do research and development and testing. This is a picture of our facility down in Oxnard, California. And what you can't see just to the left of this picture is where we assemble the batteries. That's right. We actually assemble our batteries here in the United States, which is really something I'm really proud to say, because not only does that create American jobs, but also allows us to have a high level of quality standards. It also allows us to meet market demand really quickly by adjusting what we're making in the factory to meet consumer demand. But again, this is our training facility here, where we're undergoing a lot of research and development and training to make sure that these batteries are going to be safe in real world applications. So this is that same air certification test I was mentioning, right? If you think about what's happening in the cargo hold of an airplane, they're going to go through these pressure swings, right? That's what we're going to simulate during these tests. Rapid temperature swings, which is what they simulate, vibration, and then also shock and impact. And you can see you have to have no leakage, venting, or disassembly, no fire, of course, to achieve some of these tests. Further, what they do is they then also start to short circuit the battery and then also overcharge the battery. And it really just can't catch fire, and you're allowed to achieve these certificates that allow us to airship. Going back to a little bit to the UL listing. So a lot of jurisdictions around the country will let you pull a permit for a battery system without necessarily looking at what UL listings that the battery energy storage system that you're proposing to put in has. If they're doing that, as the installer who should care about safety, should educate those installers, or at least let them know that your systems you do have that UL listings. So when you're sitting down at the kitchen table with a homeowner and you're talking about the advantages, the pricing, the features of an energy storage system, I hope that a lot of you, and I'm sure a lot of you are, talking about the safety of a battery energy storage system. And how you know a battery energy storage system is safe is you don't believe what the manufacturer says. I mean, sure, you can believe me if you want, but you believe what a third-party testing lab says. And one of the most popular third-party testing labs in the country, I would even argue in the world, is UL, Underwriters Laboratory. So UL takes the individual cells on UL 1642, subjects them to all of these kind of abusive regimen of testing, like shock, vibration, abnormal charging, forced discharge, and then they look to see if we're going to see a fire or an explosion. If they pass, we all move to the UL 1973, which is where they take those individual battery cells, put them in series and parallel configurations in these little packs, which then make up the battery module. And then they finally repeat some of those tests. UL 9540A, really kind of the gist of that is making sure that you're verifying the compatibility of these UL listed 1973 battery modules with the UL 1741 listed inverter. Really that you're not introducing any unforeseen risks or problems that might be associated with combining these two products together. I remember back in the day, what we would just kind of grab a charge controller, grab an inverter, grab a battery, and hope it all worked together. Whereas this 9540A is really vetting and testing that. There is another UL 9540A, which is a system level testing. It's not a certification. It's not a pass-fail. But what UL 9540A does is we send one of our battery energy storage systems to the UL labs. They force one of the battery cells inside a battery module into thermal runaway with propagation, and they watch what happens. What happens dictates what sort of clearance requirements you have called out in your 9540, what sort of maximum amount of capacity you can install in one location. And if you look carefully at some of these newer NFPA 855 regulations, they're starting to call out things like you can only install them 3 feet apart. You can only have a certain amount of kilowatt hours in one location. And if you, as a battery manufacturer, can prove that you can safely have batteries closer together than that and more batteries in one location than that, they allow you to circumnavigate some of those 855 requirements. So again, UL 9540A and UL 9540, if you're going to be out there quoting these systems, make sure you look for these on the spec sheets. Additionally, look for people that are making these reports public. We're very proud of our report, right? Because nothing happened with our batteries, or very little happened with our batteries. Whereas other people might hide or not share publicly that UL 9540A test report. AHJs and inspector by law are allowed access to those reports. So again, this is breaking down what I just kind of described on the 9540A, where they go through this regimen of testings, progressing from the cell module into the unit level testing. And ultimately, if you do need to go to an installation level test, where you would have to have external fire mitigation strategies installed, like a sprinkler system, for example. This is a picture I pulled out, and this is something that we talk about in some of our other talks, is how to wire our batteries. And one of the ways we want you to wire our batteries is in parallel, but not only that, but wire them in such a way that you have conductors of the same gauge and the same length go into a common terminal block, a common combiner box. That way, each battery in this battery bank is working just as hard as the next. But one thing I wanted to call out in this picture here is that there's that insulation. You can see that they've insulated this battery box so that you're going to contain any heat that is generated in this battery box inside of this battery box, and keep those batteries warm or cold if it needs be. Lastly, I kind of want to finish up again talking about how to get to the Power Academy. So get your phone out really quick. You can scan this QR code. This is going to take you to the Power Academy. You can also text LEARN to 33988, or there's the direct URL there as well. If you got a question, get it into the Q&A chat right now, because we're about to be wrapping up. And while we got Nathan with us, I want him to help us with any questions that I might not be able to help you with. On the Power Academy, there's going to be in-person, where we'll come out to your location. We'll come out and do a live in-person training. We got some travel trailers, that we got generators and energy storage systems ready to go, and we'll do some live in-person. So if that's something that interests you, my email is about to pop up here in a couple more slides. Email us. Live virtual, just like you're watching here, always available. But also what I'm always excited about is self-paced recordings or self-paced learnings. And we're always working to add, new content to the Power Academy. That's great for somebody who's at night, you got a little extra time at night. Maybe you got a little extra time waiting for some permits to come through. Go ahead and access some of our self-paced or recorded tools online. So if anybody got out their phone and got to the QR code, you're on the Power Academy. Go ahead and click login if you have an account already. If you don't, click sign up. If you sign up, it's going to ask you for an email. Perfect. You don't have to be a Briggs & Stratton dealer to access this energy storage. If you are doing generators, if you are doing energy storage, we're happy to have that conversation about setting you up as a Briggs & Stratton dealer. But go ahead and log into or go to sign up, enter in your email, and then go down and click where it says select the group you're most closely associated with. If you are a dealer, distributor, authorized installer, go ahead and click that. If you're not somebody just learning to learn, go ahead and click rep group and put in your company name, and that's going to give you access to the Power Academy. One thing that's coming to an end is the IQ installer program, which, if I haven't explained what that is yet, but if you're somebody out there installing our batteries or looking to install our batteries, and you're wanting to get on our maps, we're happy to put you on our store locator map. Email me here. The email is going to pop up in a second. We'll put you on the maps. We have a $25 cash back per battery offer that we're offering. Also, additionally, is that if you sign up within the next couple days as an IQ installer, and you're able to install that first battery, and correct me if I'm wrong, Nathan, but I think it's June 30th, we will send you $1,000. So again, sign up in the next couple of days, get your first install done before the end of June, and you're going to qualify for $1,000.
That's right, Daniel. Our Elite Installer program, we have, it's been a popular promotion, and it was originally supposed to end on March 31st, but we had so many installers signing up to receive this $1,000 bonus that we decided to extend it. But we really will not be extending it again. The last day to sign up by is the 30th. And so if you're interested in becoming one of our elite installers, these are companies that install SimpliPhi batteries. Now is a great time to do it. Sign up by the 30th and install your first battery by June the 30th. And we'll send you a check for $1,000. In addition to that, each battery that you do install as an elite installer, you get another check for $25 per battery. So if you install 10 batteries and you've signed up for this elite installer bonus, we'll send you a check for $1,250. It's a good deal, and we don't normally have promotions this big that we can offer to the installers. So it makes Daniel and I pretty happy that we're able to get you guys a lot of money back for just participating in this program. The program is free. It just gives you extra rewards, and it gives us a chance to connect battery customers with installers that are offering battery solutions.
Absolutely. Absolutely. Thank you, Nathan. So that being said, there's the email, training@simpliphipower.com. If you're looking for your NABCEP credits, go ahead and email training@simpliphipower.com. Please include your name, your first name and your last name. Spell it out for me so I can get it on your continuing education credentials correctly.